These are the fluorine, chlorine, bromine, and iodines. And halogen derivatives means the organic compounds which contains these fluorine, chlorine, bromine, iodine. In this, hydrogen atoms of aliphatic or aromatic hydrocarbons are replaced by halogen atoms, means one or more hydrogen atoms are. Some students raise their hands, just we will. Yes, whatever you have problem, please write in a chat box. Students, if you have any doubt, please put your message in chat box. Okay, so we will proceed. The classification of halogen derivatives. Halogen derivatives of hydrocarbons are classified in two ways. You know, hydrocarbons means these are the compounds which contains hydrogen and carbons. In 11th standard, we already studied the many hydrocarbons like alkanes, alkenes, alkynes, and aromatic compounds. So, on the basis of hydrocarbon skeleton to which halogen atom is bonded, if halogen is bonded to the alkanes, it is called as haloalkanes. If the halogen is bonded to the alkenes, it is called as haloalkenes. And if halogens are bonded to the alkynes, it is called as haloalkynes. And in case of haloarenes, means if halogen is bonded to the aromatic system, these are called as haloarenes. I will give some examples. See in this first example, this is X and this is a alkane. This is X and this is alkene. This is X, this is alkyne, this is X, and this is aromatic system. See? So you understand these are the examples of haloalkane, haloalkene, haloalkyne, and haloarene. On the basis of number of halogens, halogen derivatives are classified as mono, di, tri, or polyhalogen derivatives depending upon the number of halogens. If one hydrogen is replaced with one halogen, it is called as monohalogen derivatives. See the definition of monohalogen derivatives. If one hydrogen atom of aliphatic or aromatic hydrocarbon is substituted by one halogen atom, the compounds formed are called as monohalogen derivatives. Monohalogen means single halogen is there, one hydrogen is only replaced. See the examples of monohalogen compounds. This is a haloalkane and this is haloarene, only one hydrogen is replaced. Polyhalogen derivatives means more than one hydrogen atoms of aliphatic or aromatic hydrocarbons are replaced. These are called as polyhalogen derivatives. Further, these polyhalogen derivatives are classified as dihalogen derivatives, trihalogen derivatives, then tetrahalogen derivatives, depending upon the number of halogen atoms are replaced. See the dihalogen derivatives in this case, two hydrogen atoms are replaced with two halogens. See this example is given CH2Cl2. This is methylene dichloride and this is ethylene dichloride, in which two hydrogen atoms are replaced with two chlorines. In these two hydrogen atoms are replaced with two chlorines. And this is one example is given dihaloarene. In this, two hydrogens are replaced with halogens. Halogens means fluorine, chlorine, bromine, or iodine. This is a 1-2 position. It is called as ortho position. If this X and another X is at 1-3 position, it is called as meta position, and 1-4 position is para position. In 11th standard, chapter number 15, aromatic compounds, we already learned this. Trihalogen derivatives means 3 hydrogen atoms of aliphatic or aromatic hydrocarbons are substituted by the 3 halogen atoms, and the compounds formed are called as trihalogen derivatives. I will give one example, CHCl3. In this 3 hydrogen atoms are replaced with 3 chlorines, CHI3, iodoform. Also in these 3 hydrogen atoms are replaced with 3 halogens, and this is a trihaloarene. See here, 3 X are there, means 3 hydrogens are replaced with 3 halogens. Then the tetrahalogen derivatives, in this 4 hydrogen atoms of aliphatic or aromatic hydrocarbons are substituted by 4 halogens, and the compounds are called as tetrahalogen derivatives. See this example, CCl4. All the 4 hydrogens of methane are replaced with chlorine here, and in this all the 4 hydrogens are replaced with bromine here. The name is carbon tetrabromide, carbon tetrachloride. If the fluorine is there, it will be carbon tetrabromide, and if the iodine is there, it will be carbon tetraiodide. And in case of aromatic system, see here 4 hydrogens are there. 4 hydrogens are replaced with 4 halogens, 1, 2, 3, 4. It is called as polyhalogen, tetrahalogen derivatives. Now the classification of monohalogen derivatives. Monohalogen, in this only one hydrogen is replaced with halogen. So there are again 2 types on the position of halogen, where the halogen is attached to the carbon, and types of hybridization. Directly I will give you examples. Alkyl halides or haloalkanes. Haloalkanes are also called as alkyl halides. I will give the examples of it. Alkyl halides in 11th standard, you know the examples of alkyl halide because the functional group is there, alkyl halide, RX group. R means the alkyl group and X is halogen. In this, 1 hydrogen of alkane is replaced with halogen. It is called as alkyl halides. Remember, there are 3 types of alkyl halides: primary, secondary, and tertiary. Say this is a primary. Why this is primary? Because this X is attached to carbon. This carbon is primary. In 11th standard already we studied what is mean by primary carbon, what is mean by secondary carbon, and what is mean by tertiary carbon. Again, I am going to explain here. This halogen is attached to the carbon, and this carbon is primary because this is attached to the only one carbon. This is a secondary halide because this X is attached to the carbon, and this carbon is secondary because this carbon is attached to another 2 carbons here, 2 R groups. That's why it is secondary halide. And in case of tertiary halide, see this X is attached to the carbon, and this carbon is attached to 1, 2, and 3 carbons. That's why this is a tertiary halide. Then the next point is, these are some examples of primary alkyl halide. This is already discussed now. So I will not again explaining this primary, secondary, and tertiary. This is a new part, allelic halides. See this allelic halides in which halogen is bonded to the sp3 hybridized carbon atom next to the carbon-carbon double bond. In this example, you can clearly see this X is attached to the carbon and this carbon is attached to the carbon-carbon double bonded. If such type of system is there, this is called as allelic halides. Allelic halides means carbon is bonded to the actually sp3 hybridized carbon, and this carbon is bonded to the another carbon-carbon double bond. See here also, this halogen is attached to the carbon, which is sp3 hybridized, and this is attached to the carbon-carbon double bond. Such type of organic system is called as allelic halides. Then the benzylic halides, in which the halogen is attached to the carbon and the carbon is attached to the another benzene ring. Clearly we can see here, benzylic means this is different than allelic. See here, X is attached to the carbon and this carbon is attached to the benzene ring. If such type of system is there, this is called as benzylic halide. Then vinylic halide. In this, all these examples are in this halogen attached to the sp3 hybridized carbon atom, but in case of vinylic halide, The halogen is bonded to the sp2 hybridized carbon atom. Remember the sp2 hybridized carbon atom which contains carbon-carbon double bond. This is called as vinylic halide. See this example, X is directly bonded to the carbon, double bonded carbon. See also here, X is bonded to the double bonded carbon, which is sp2 hybridized. This is sp2 hybridized, and see the previous example. See the previous example. This X is attached to the sp3 hybridized carbon. This is X is attached to the sp3 hybridized carbon, and this is attached to the benzene. So all these benzylic, vinylic, and allelic halides already I have explained. Then haloalkyne. The name itself suggests in this halogen is bonded to the sp hybridized now. Sp hybridized carbon means which contains carbon-carbon triple bond. See this example. X is attached to the carbon and this carbon is sp hybridized because this is carbon-carbon triple bond. Then aryl halides or haloarenes, in this hydrogen is directly bonded to the aromatic system, which is sp2 hybridized aromatic ring. See this example, X is directly bonded to the sp2 hybridized aromatic ring. Such type of organic compounds are called as aryl halides or haloarenes. So this is ortho 1,2 position, 1,2 dibromobenzene. This is 1,3 metadibromobenzene or 1,3 dibromobenzene, and this is a 1, 2, 3, 4. 1, 2, 3, 4. 4 chlorine atoms are there. 4 hydrogens are replaced. These are the examples of haloarenes. So the classification part is completed. Now these are some names of halogen derivatives here. See, in this chart, there are names of some halogen derivatives are given. These are the common names.